So in the last class, I had said that write a logic to latch two output Q0 and Q1 with I0 and unlatch using I1. Now I am owning this both the outputs using single switch, okay, and I'm unlatching using another single switch. So you can use two rungs or you can do in a single rung, okay. Both are right, okay. This is I0, Q0, okay. So I am latching, okay. So now I can use same switch Q1, okay. And I'm unlatching using, sorry, I1. This much you understood? Using two
Madam.
rungs?
Yes, madam. This one understand, madam.
Okay. Now to do with the single rung, now you see here that is there any difference in the input condition to the outputs? For both the output, am I not giving the same input? See, I am using I0 to on it, I1 to off it, and I am latching. Okay, now according to the second rule, inputs can be connected in series or parallel, whereas output can be connected only in parallel. So there is a provision that I can connect my output like this. Okay, so I will utilize that. Condition is that you should have a same input condition. Okay, if you have a different input conditions, you cannot directly connect it parallel because it might not work properly. You have seen in the previous examples, correct?
Yes,
Okay, now since I have the same input condition, I'll take I0, Q0, I will take Q1. Now to latch it, I can take any one condition. Okay, either I can take Q1 or Q0. So I'll go with Q0. To unlatch it, I will use I1. Okay, understood?
Yes, ma'am.
Now, this is using only the switches. So now the second condition was you have to use the set and reset, right?
Yes, ma'am.
So to set and reset, it's simple. So I use a switch I0 or 0 and I'll take set Q
One more
0,
set.
one more set. To reset,
Yes, ma'am.
any confusion?
No, no.
no, madam.
Clear, right?
Yeah.
Okay, shall we proceed to the next topic?
Okay, ma'am.
Okay. So now next topic is rising and falling edge, okay? Or rising positive edge or negative edge. So however you want to call it, you can call it. So can anyone tell me what is this rising edge and falling edge? Can anyone tell what is rising edge and falling edge?
No idea.
Lower level to higher level for the
Satya,
rising.
please off your mic.
I'm telling the answer, ma'am. You are question.
Okay, sorry, I got confused. Some disturbance was there.
Yeah.
You said you can't attend the class, right?
Yeah, yeah. But my friend is going to the some work, so that.
Okay, fine. Now tell me the answer. What is rising edge and falling edge?
Okay, rising edge means lower level to higher level.
Okay.
Uh, And falling level means higher level to lower level.
Okay, correct. So this is a edge detection. So whenever we take a clock pulse, so whenever we giving a input, like a digital input we are giving, we'll be using a clock pulse, okay? A clock pulse like this. So this is a zero state and this is one state. Now, this is a positive edge and this is a negative edge. This is also, this is a positive, this is negative. Here, negative means not a negative value, negative means zero. Okay. Now, whenever we use the clock pulse, the complete for this cycle here, whenever this condition reaches here, during this state, the outputs will get on. Okay. Now, when here one more condition comes, that is whenever we are rising from 0 to 1. Okay. Whenever we having a transition from 0 to 1, so that it's a high condition. So we can operate, we can make any signal on between this transition. Okay. And this happens in very like in microsecond, in nanoseconds. Okay. Similarly, when there is a negative edge, okay, when there is a transition between 0 to 1, sorry, 1 to 0, so that time also we can use to energize the output. Okay. So this is called a scan cycle. Okay. Now, so whenever if there is a transition from 0 to 1, then it is a rising edge or positive edge. Whenever there is a pulse we are considering from 1 to 0, that is transition from 1 to 0, then it is a negative edge. Okay. This is about the concept. Now, whenever we take a switches in, like whenever we take a NO contact, there is a special option selecting the uh, rising edge or falling edge. Okay, or we can say it as up or down, positive or negative. During that transition, during this smallest tiny period, we can energize our outputs. Okay, shall I show it in the program?
Ma'am, can you tell once again negative side?
Okay, negative side is nothing but see. Now this is one clock pulse. Okay, so here it has a low and high. Now can you see here? It is a taking a transition from 0 to 1 or from low to high. Similarly, the falling edge side, the other side, it is taking a transition from 1 to 0. Okay, that means it is it is reducing from high to low. This is called negative edge. Okay, so that time also it will give a high signal only. Okay, not only we are taking the it doesn't mean that whenever it is going from 1 to 0, it will only give a high signal low. When it is going from top to bottom, that time also high signal pulse will be generated. That small signal is used to energize the outputs. Okay.
Okay. Totally, we are calling from the CAN cycle, ma'am. Scan scale.
Scan cycle. This tiniest thing is there, no? This is
Yeah.
one scan cycle. Okay.
Okay.
So actually, it is not. There is no gap also. To make you people understand, to understand what like how it is there. So they have represent like this. There is a small clock. Okay. Actually, it is just a straight line. Okay.
Okay.
ಮೇಡಮ್ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಇವಾಗ ನಮ್ಮ ಹತ್ರ ಪುಷ್ ಬಟನ್ ಇದೆಯಲ್ಲ ಅದು
ಹಾ.
ಪ್ರೆಸ್ ಮಾಡಿದಾಗೆ ರೇಸಿಂಗ್ ಎಡ್ಜ್ ಆಗುತ್ತೆ, ರಿಲೀಸ್ ಮಾಡಿದಾಗೆ ಫಾಲಿಂಗ್ ಎಡ್ಜ್ ಆಗುತ್ತೆ ಅಲ್ವಾ?
ಹೌದು. So this is called a PLC scan time as well. Okay. This whatever rising edge is there. Okay. So in Omron PLC, it is called as up and this is called as down. If you take a Siemens PLC, then it is a positive edge and this is a negative edge. Okay. Names will differ. So select the NO coil. Now give the address. Okay. Then go to details. If I just give address, I'll get a normal NO contact. Okay. I don't know whether it is like it is not neither up or down triggered. Okay. So for that, Select the NO contact, go to details. Here in the differentiation, you have the option none, up and down. Okay. So none means it's a normal NO contact. If you use up, so it will become a positive edge triggered. Okay. So, and the representation will be like this. So there will be a rising arrow. Okay. Indicated. Understood? How to take a positive edge triggered contact?
Okay.
So then take the output. Now let's see whether can we observe the output or not, because it is a tiny time period where the output will get on only for that particular time. Okay, not to the whole clock pulse it will be on. Only that particular region, the increasing, the transition from 0 to 1, only during that period it will be on. Okay, so I'll simulate now. So I made it on. Did output got on? Did output got on? Can anyone confirm?
No, madam.
No, right? You're not seeing anything, right?
Yeah.
Because between it is only the transition from 0 to 1. Now what I will do for the same contact, I'll take a set. Okay. So
Latch also.
not latch, I'll show you. Wait. I'll take a switch. Now I have taken a set instruction, okay? Even for the minutest state, even if it sees a small high condition, the set bit will get high, okay? It need not to have a complete pulse or complete high state signal only, okay? Even for the small transition, the set will get high. So now I will operate this one. See, this output is not getting on, but the set bit is getting high. Understood?
Yes, ma'am.
Okay, how exactly it is working is that. So let's take an NO contact. Okay. Now, whenever I make it on, let's say it was off for 5 milliseconds. Whenever I make it on, it will be on like this. Okay. Let's say this is the awning period of a switch, whichever I'm considering, switch one. Now the output will get on for this particular period. Okay, this is my output. Now can you see this output is getting on completely, correct? Whenever the switch is on, it is considering whole. Okay, because output want the particular region to get on. Okay, so this is the complete high state it needs. Now what I'll do for the same output, I gave only this much pulse. Okay, but this is my switch with positive edge. Okay, now the output will not recognize it. Okay, because it has a delay here. Can you see this delay? There is a delay in awning period. So it has to, the input should be on for this particular time. Then only the output will detect it. But this positive edge is getting a peak only for this, only at this rise condition, correct? It will not take that. Therefore, the output will remain in the off state, not in the off state, sorry. So it will get on and immediately it will get off. So, but we can't see it in our bare eyes because this process will happen in nanosecond. But if I take the same thing to a set output, okay, I'll take to a set output. So this set will see this transition, okay? It will observe this transition 0 to 1. So even for this minutest change, it will get on and continuously, it continuously remains on until you won't reset it. Okay? Understood?
Okay, ma'am.
Any any confusions?
No. And negative
No,
side is
right?
no, nothing, ma'am. Negative side is going to the opposite side. No, ma'am.
Yeah, negative side will come this side. So I'll show that also. Wait.
Okay. That is the opposite time when the opposite also that.
Whenever you're offing the switch, okay?
That is the
During
opposite.
yes, during this period.
Okay.
Okay, during this transition, it will get on.
Okay.
Okay. Wait, I'll show that also.
We want to set the reset button, ma'am.
Yeah, whenever you're using set, it is mandatory you have to use a reset, okay? Set and
Okay.
reset goes together in the program.
Okay.
See, now I have made the switch on, but it is not getting on, correct? Because I have used a falling edge. Whenever there is a transition from 1 to 0, that time it will get on. Now I'll use set off. See, now in the off state, it is getting on. Understood?
Okay, ma'am. One more thing. This is the when the set is using that the negative side.
Hmm.
We are using the reset button also, ma'am.
Yes, see, here in this program, I have not taken a reset. Okay. I have
Okay.
just taken set and I have explained to you. So whenever you are doing a program, whenever you are using a set instruction, you have to go along with the reset instruction because once it gets set, okay, it will not
Okay.
get reset unless you won't reset it. Okay. Therefore,
Okay.
whenever you are using set instruction, go with the reset. Okay.
Okay.
And you have to use the same address, not a different address.
Okay.
Okay. So clear, rising edge and falling edge.
Madam, actually, you given different inputs in a set.
I have given different outputs because I cannot repeat the output address. Okay. Here I've considered
Input also different, no?
here I can give the same input. Just for understanding purpose, I have taken the different. I'll give a same. Okay, fine. So that time you can understand more clearly.
Yes.
So now when I make it on, so since it is a rising edge, this
Yes,
will
ma'am.
get on. So now when I make it off, this will get off. Okay. Since I haven't used the reset, it will remain in the on state. Okay. For this, I have to use a reset as well. Got
Yes.
it?
Got it.
Clear to everyone? Any other doubts? So you'll select us. Then go to this function block. Okay. Select this one, place it. If you know the command, directly type the command, give a space, then address. If you don't know the command, go to details, go to find instruction. So here you want the output, correct? Go select the sequence output. Here in this one, you will find set and reset, okay? Select set, then give okay. Here in the operand, it will ask for operand. So give the address, the output address, okay? That's it. Got it?
Got it.
Do it.
Madam, in one rungs, can we use both raising edge and falling edge?
No, you cannot. Because two different operations, right? It will show error. Check it out whether you can do it. If I take one more switch,
No, ma'am. I'll latch the output for input, and then I'll use for falling edge.
then you lose for falling it. Check it out whether it will work or what. When you have set instruction, why are you going for latching and unlatching? See, you have set and reset, right? To avoid the latching condition only, they have come up with the set and reset instruction. Correct? If you want to do it, check with from the basic, like what happens with the latching, unlatching, then go for set and reset, then go for rising edge and falling edge. Go for it. Okay. So simultaneously execute it, you will get the errors. Okay. Like what are the problems will happen, you will come, you will know about it. Okay. Check it out. No problem.
Okay.
Others, it's okay. What about Gopi, Sushant?
Same, I have facing some network issue, ma'am. So I can't able to
Sushant, you're facing network
understand
issue.
today class, ma'am.
Okay,
Yes,
fine.
ma'am.
Please, I'll upload the video. Please go through it. If you have any doubt, ask in tomorrow's session. Okay?
Okay.
ಮೇಡಮ್ ನನ್ನ ಹತ್ರ ಲ್ಯಾಪ್ಟಾಪ್ ಇಲ್ಲ ಇವಾಗ. ಹಲೋ.
It's okay, Mallikarjun. Solve ಮಾಡಿ. ಇವಾಗ್ಲೇ ಮಾಡ್ಬೇಕಂತ ಏನಿಲ್ಲ.
ಓಕೆ. ಅಲ್ಲೇ ನೀವು
ನೀವೇನಾದ್ರೂ
ಅದೇ ಟ್ರೈ ಮಾಡಿ.
ನಾನ್ ಟ್ರೈ ಮಾಡ್ಬೇಕಾ? ಸೊ ನೀವೇನಾದ್ರೂ ನಿಮ್ದು ಅವಾಗ ಹೇಳಿದ್ರಲ್ಲ ಅಪ್ರೋಚ್ ಅದ್ ಇದು ಮಾಡಿದ್ರೆ ನಾನು ಎಕ್ಸಿಕ್ಯೂಟ್ ಮಾಡ್ತೀನಿ. ಲ್ಯಾಚಿಂಗ್ ಅಂಡ್ ಅನ್ಲ್ಯಾಚಿಂಗ್ ಬರ್ದು ಕಳ್ಸಿದ್ರೆ
ಹಾ ಸರಿ ಕಳಿಸಿ.
ಫೋಟೋ ಕಳ್ಸಿ ನಾನು ಅದನ್ನ ಎಕ್ಸಿಕ್ಯೂಟ್ ಮಾಡಿ ತೋರಿಸ್ತೀನಿ.
ಓಕೆ.
ಮಲ್ಲಿಕಾರ್ಜುನ್, ನಿಮ್ಗೆ ಇದು ಆಪರೇಷನ್ ಅರ್ಥ ಆಗಿದೆ ಅಲ್ವಾ? ರೈಸಿಂಗ್ ಎಡ್ಜ್ ಯಾವಾಗ ಆನ್ ಇರುತ್ತೆ, ಫಾಲಿಂಗ್ ಎಡ್ಜ್ ಯಾವಾಗ ಆನ್ ಇರುತ್ತೆ ಅಂತೇಳಿ.
ಎಸ್ ಮೇಡಮ್.
ಓಕೆ.
Madam,
ಹಾ ಹೇಳಿ ರಾಧಾಕೃಷ್ಣ.
rising input, how to get actually I'm not getting instruction list.
ಒಂದ್ ನಿಮಿಷ ತಡೀರಿ, ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡ್ತೀನಿ. See, Mallikarjun, see here, when I set on, this is getting on only for a particular period. This can't read, okay? This will get on only when you make it off. Okay? So when I make it off, that time it will get on. It will give a high signal. But from this side, you're not getting any high signal, no, because you made it off. So this combination won't work. Okay?
Okay.
That's why whenever we are using rising edge and falling edge, we'll go for set and reset instruction. Okay?
Thank you.
Now, Radhakrishna, what you will be doing whenever I explain? Every time you'll ask for this thing, repetition. Now see, whenever you select this, go to details. Here there is a differentiation option. Select up or down. Okay. First, give the input address. Then select the up. Then give OK. Now, go to the function block. Give set 100.00. Enter. Okay. Make it fast. Anybody else? Do you guys have any other doubts? Is it okay?
Yeah, okay, madam.
So see, you guys please go through everything once. Whatever you have doubts, please clear it out by tomorrow, okay? Within half an hour, so that we can start with timers from tomorrow, okay? Once we start with timer, the timers counters goes along, okay? So if you
Okay.
have any doubts, please clear it out regarding this set, reset, falling edge, rising edge, latching, unlatching. If you have still confusion in the basic ladder programming, connecting parallel series, okay, please check everything once. Then we'll go for the timers. Okay.
Okay. Madam, what are the things you are going to tell, madam? Timers, count. Next.
Timers, counters, then it is your comparison, arithmetic comparators are basic mathematic operation, jump and subroutines, then shift registers, then what else you have? Yeah, jumps and subroutines. Yeah, that much. The next topic. Then in the other part, you have PID, PWM. Then you have analog scaling. Then you have how to connect analog inputs and outputs. The scaling factor. Okay, this much is for the PLC.
Madam, data transfer, move instruction.
Move instruction. Move
Yeah.
instruction that that move instruction it's okay, that is also sure shifting the values. Move instruction. Move instruction is nothing but using a move command from one register to other register. Simple.
Oh, madam, that one binary to decimal, decimal to binary, some conversation is
Data
come.
data conversions.
In
Okay.
Delta PLC, I didn't get anything.
Okay, fine, I'll do that. No worries. Okay. Anything else?
Okay, ma'am. Can you send some syllabus copy of the PLC?
Huh?
Syllabus copy.
Syllabus copy. You guys have got the brochure, right?
That's one not, ma'am. You tell it's timers like that.
See, whatever was there in the brochure just now I said same thing. Wait a minute.
ಮೇಡಮ್ ಇವಕ್ಕೆಲ್ಲ ಇನ್ಸ್ಟ್ರಕ್ಷನ್ ಅಂತ ಹೇಳ್ತಾರಲ್ಲ,
ಯಾವ್ದಕ್ಕೆ?
ಇವಾಗ ನೀವೆಲ್ಲ ಹೇಳಿದ್ರಲ್ಲ ಸಿಲೆಬಸ್, ಇದಕ್ಕೆಲ್ಲ ಇನ್ಸ್ಟ್ರಕ್ಷನ್ ಲಿಸ್ಟ್ ಅಂತಾರಲ್ಲ.
Instruction list is a programming type. ಇದಕ್ಕೆ ಬರೀ ಇನ್ಸ್ಟ್ರಕ್ಷನ್ಸ್ ಅಂತೀವಿ. ಇನ್ಸ್ಟ್ರಕ್ಷನ್ ಇದ್ರಲ್ಲಿ PLC ನಾವು ಸ್ಪೆಸಿಫಿಕ್ ಆಗಿ ಹೇಳಿದ್ರೆ ಇನ್ಸ್ಟ್ರಕ್ಷನ್ ಲಿಸ್ಟ್ ಅಂದ್ರೆ ಒಂದು ಪ್ರೋಗ್ರಾಮಿಂಗ್ ಲ್ಯಾಂಗ್ವೇಜ್ ಆಗುತ್ತೆ. See, in the instruction you have bit memory, word memories, okay, and constants. So I have finished bit memory. Word memory comes whenever we go for the arithmetic operation. Then latching and unlatching, set, reset, rising edge, falling edge, timers, on, off, pulse, retentive, counters, up counter, down counter, up and down counter, increment, decrement, move, comparator, arithmetic operation blocks, conversion, shift registers, jump and subroutine. Okay.
Okay.
Then analog scaling, current and voltage signal from PLC to IO, PID control, PWM. ಮಲ್ಲಿಕಾರ್ಜುನ್ ನೀವು ಟೈಮರ್ಸ್ ಕೌಂಟರ್ಸ್ ಆಗಿದ್ಯಾ?
ಹೇಳಿದ್ದಾರೆ ಮೇಡಮ್, ಹೇಳಿದ್ದಾರೆ. ಟೈಮರ್ಸ್ ಕೌಂಟರ್ಸ್ ಹೇಳಿದ್ದಾರೆ ಮೇಡಮ್, ನೀವ್ ಹೇಳ್ತಾರೆ ಹೇಳಿಲ್ಲ.
ನಾನು ಇನ್ನೂ
ಅದು
ಹೇಳಿಲ್ಲ ಬಿಡಿ ಟೈಮರ್ಸ್ ಕೌಂಟರ್ಸ್.
ನೀವ್ ಹೇಳೋ ಇದನ್ನ ವೇನೆ ಡಿಫ್ರೆಂಟ್ ಆಗಿದೆ, ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಆಗುತ್ತೆ ಬೇಗ.
Okay. So finished everyone? Radhakrishna?
Doing, ma'am, doing.
No, you are the one of the slowest person I have ever seen. One problem, like problem ಮಾಡೋದಕ್ಕೆ ಇಡೀ like 1 hour session ನ ತಗೊಳ್ತೀರಾ ನೀವು. ಇನ್ ನಿಮ್ಗೆ ಏನಾದ್ರೂ ಟೈಮರ್ ಕೌಂಟರ್ ಪ್ರಾಬ್ಲಮ್ ಕೊಟ್ರೆ ನನ್ ಕತೆ ಏನು?
Madam, actually, in this software, we get instruction is very typical, ma'am. That's why.
So always keep open your help window. If
Actually,
you're
C++
facing problem
is the
in
best
finding the
method.
instruction, open your help window, you will get all the comments. Okay.
Again, this Omron PLC typical to me, man. Siemens is best for simple and easy.
Omron PLC is difficult
Yes, ma'am.
and Siemens PLC is easy.
Yeah.
The easiest PLC is Schneider Electric PLCs. They are very,
Wow.
very easy to learn.
Delta, madam, I thought Delta was easy.
No, Delta and Omron are a bit confusing because every time you need to remember the instruction. In Schneider PLCs, they are very concised PLCs. They are very easy PLCs. So if you want to learn ladder all the programming, download SO Machine Basic. Okay, the Schneider Electric software. That is really nice.